Hi everyone. Today we will continue on discussing the standard equation of a parabola, this time with vertex at HK there. So try to get your module again. You open your module and let's try to discuss standard equation of a parabola, this time with vertex at HK. So the first one, we have quantity x minus h squared is equal to 4a quantity y minus k, wherein the principal axis is x equals h. So let's take a look at the example. In this example, we are going to find for the principal axis, the vertex, the focus, directrix, and points of focal width, length of focal width, and then finally we are going to sketch the graph. So let's try solving the equation quantity x plus 1 squared equals negative 4 quantity y minus 3. So first, we will be getting the principal axis. It's letter A. Since the equation, so this equation of the parabola has the form, so this it has a form x minus h squared equals 4a y minus k, and this equation here can be written as, so if we are going to rewrite this one using this form, it is now in the form x minus negative 1 squared is equal to negative 4 y minus 3. So this equation here could be written this way, and so from there we can now have the value of our h there, so h here, which is negative 1, and it has principal axis where x is equal to negative 1. So the principal axis is x, which is equal to negative 1. So that is now the principal axis. The next one, we have the vertex. So how are we going to get the vertex? So the vertex of the parabola would be, so the vertex, its coordinate now would be at negative 1, so h and k. So remember, this we have h and k. So for the vertex, we have now h, which is equal to negative 1, and we have now the value of our k there, k. So we have positive 3. So the vertex now has a coordinate negative 1, 3. Next, so let's consider the focus. So if you can still remember, in considering the focus, we have 4a, wherein we have there now 4a, which is equal to negative there. So we have 4a, which is equal to negative 4. So I'll be writing here negative 4. Therefore, a would be equal to negative 1. Okay? So consequently, the directed distance of the focus from the vertex is negative 1 unit. This implies that the focus is 1 unit below the vertex, having the corresponding coordinates. So we have there now the coordinate of negative 1 and 2. Then next, we have the directrix. Let's do the directrix. So the directrix is a horizontal line which is the absolute value of a. So a is the absolute value of -1. So taking the absolute value, that would be now equal to 1. So we have 1 unit above the vertex. So the directrix is given by y is equal to 4. Okay, then letter E. Letter E, the endpoints of the focal width. So since the directed distance of the focus from an endpoint of the focal width is 2a, we have the absolute value of 2a. Then we have now the absolute value of 2 times -1. Therefore, we have negative absolute value of -2, and the absolute value of -2 is +2. So meaning we have 2 units to the right and to the left of the focus. The endpoints now of the focal width are with the coordinates -3, 2, and 1, 2. Then we have now finding the length of the focal width. Okay, so how are we going to find the length of the focal width? So the length of the focal width is given again by absolute value of 4p. So so this is 4a. So we have 4 times a is -1. So 4 times a is, we have -4, and the absolute value of -4 is 4. Okay, so let's now for the final answer. So let's now have sketch the graph. So here we're going to sketch the graph. So the first thing to do is to get the principal axis. Okay, so still the principal axis is x. So in the x-axis, where is equal to -1. Okay, here. And then the vertex of the parabola is -1, -1, 3. So -1 and then +3. That's now the vertex. And then next is the focus. So the focus is -1, 2. So the focus here, we have it here. Let's have now letter C. Letter C, which is the focus. So we're going to graph again. Where's the focus there, which is equal to -1, 2. So -1 and then +2. So there's the focus. Then the directrix. Okay, the directrix, which is y is equal to 4. So the directrix, y is equal to 4. There, 4. Okay, and then we have the endpoints of the focal width, which is -3. There, -3, 2, and 1, 2. So that's the end of the focal width. And then the length of the focal width. So the length of the focal width is 4. So we have there 1, 2, 3. There's now 1, 2, 3, 4. Okay, there you have it. So that's the end of the focal width. So from here, so 1, 2, 3, 4. Okay, that's now the length of the focal width. So that is for our example number 1. Our next example would be finding the standard equation of a parabola with vertex at hk. So here now we have quantity y minus k squared equals 4a quantity x minus h, where the principal axis y equals k. So still we will be finding the principal axis, vertex, focus, directrix, endpoints of focal width, length of focal width, and then sketch the graph. So here's our next example. we have quantity y plus 2 squared equals 1/2 x. So, here, since the form of the equation is y minus k squared equals 4a quantity x minus h, it can be written, so this equation here can be written as y minus negative 2 squared there equals 1/2 x minus 0. So here our principal axis would be, okay, so letter A, our principal axis would be the parabola, which is y equals negative 2. So here we have y minus k, so this is our principal axis, where k now is equal to negative 2 there. Therefore, the principal axis is y equals negative 2. Then the next one, we have the vertex. So the vertex is hk. So our vertex would be, so our vertex would be 0 there, and then our y would be negative 2. So that's now the coordinate of our vertex. Then letter C, we have the focus. So the focus is given by the equation 4a. Okay, so 4a, there we have it there, 4a, which is now equal to 1/2 there, 1/2. So 4a equals 1/2. 4a equals 1/2. So we have now a is now equal to 1/8. And then letter D. Letter D will be the directrix. So the directrix, oh, by the way, we have there the coordinates. So we have 1/8 and negative 2. Then we have the directrix, which is given by absolute value of A. Oops, there. Absolute value of A, which is now equal to 1/8 units. Okay. Then letter E. Letter E, which is now the endpoints of the focal width. So the distance of the focus from the endpoint of the focal width is 2a, which is equal to 1/4. Therefore, A would be moving 1/4. So we have 2a, the absolute value of 2a, which is equal to 1/4. Therefore, we will be moving 1/4 units below and above the focus. So our coordinates now would be 1/8, 9/4, and 1/8, 7/4. Okay. Then letter F. Letter F would be the length of the focal width. So the length of the focal width would be the absolute value of 4p. So the absolute value of 4a. So the absolute value of 4a. So 4 times 1/8, we have now 1/2. So it is 1/2 unit. That's our focal width. For the graph is left for you to do it. Okay, so I'll repeat. We have the axis, principal axis is y is equal to negative 2. The vertex is 0, negative 2. Then, the focus, so we have for A equals 1/2. So, A now would be 1/8. We have there the coordinates. Then, the directrix, we have absolute value of A. So, the absolute value of 1/8 is 1/8. And then, the endpoints of the focal width, so we have the absolute value of 2A. So, we have 2 times 1/8. We have 1/4. So, meaning we have 1/4 unit below or above the focus. So, we have the endpoint. And then letter F, we have the length of the focal width. It's given by absolute value of 4A. So, 4 times 1/8. So, we have 1/2. Meaning, we have 1/2 unit. That's all for today. Good day.